Hey guys, so we are going to go over our Unit 5 test review. So first things first, we have to determine if the triangles are congruent. So we're going to use one of these 5 or say none if it doesn't use any of those characteristics. So if we look at our first one, we have an angle and an angle, and a side in between. So this one is angle, side, angle. If we look at our next one, we have 2 pairs of congruent sides, and then we have that third side in the middle that has that reflexive property. So that one is side, side, side. On C, we can use vertical angles to prove that those 2 angles are congruent, but if we spell that out, we have angle, side, side. Angle, side, side is not one of our options, so C is none. And on our last one, we have a right angle. This one and this one is going to be our hypotenuse. These two are our legs, so D is congruent by HL. On to number 2. Number 2 says, given the figure below, determine what must be congruent to use the AAS method, so the angle, angle, side. So we already have that angle in the middle here. So we have to go angle, angle, side, which means G has to be congruent to E. Okay, we can't use those other angles because when you place it down at the bottom, it would become angle, side, angle, and it specifically says angle, angle, side. So naming with 3 letters, we're going to have angle HEF. If you have it backwards, FEH, that's okay too. And then it's got to be congruent to JGF. Again, if you have it opposite with FGJ, that is okay. Then the last thing is just doing the congruency statement. So when we do this congruency statement, I'm going to start at F, and then I'm going to go to G and down to J. So FGJ. So we're going to start at the same spot because this angle F is congruent to the angle F in the left triangle. So F goes to E, and then down to H. So FGJ is congruent to FEH. All right, number 3. So number 3 says find the values of x. If we use our reflexive property in the middle, these 2 triangles are congruent by angle, side, angle, which means that angle Q is congruent or equal to angle S. So that means x squared plus 5x is equal to 11x plus 40. From here, since we have that squared, that means we're going to have to factor. So we need one side set equal to 0. So we're going to subtract 11x and 40 from both sides. 5x minus 11x is negative 6x minus 40 equals 0. And then we have to find 2 numbers that multiply to give us negative 40 and add to give us negative 6. When we do that, we're going to have 10 and 4. So to add up to negative 6, we're going to have a negative 10 and a positive 4. Then we have to take both of those 2 things, and we're going to set them each equal to 0. Oh, yeah, equal to 0, sorry. And then x equals 10 and x equals negative 4. Our last step is to plug them into our 2 original equations. So when we plug 10 into x squared plus 5x, we're going to get a positive number. If we plug 10 into 11x plus 40, you get a positive number. So 10 checks out. It is a valid answer. The last thing we have to do is plug in negative 4. So if we plug in negative 4, we're going to get negative 4 squared plus 5 times negative 4. So negative 4 squared is negative 4 times negative 4, which is 16 plus negative 20. And that's going to give us negative 4 as an answer, which you can't have. You can't have a negative answer. So negative 4 is not a valid answer. It's just x equals 10. So moving down to number 4, we have x squared and then 4x plus 45. Since 57 and 57 are the same on both sides, it means that x squared is equal to 4x plus 45. So if you remember, if you have an equal angle, then the opposite sides are equal as well. So we're going to do the same thing here. We have to factor. So we have to get that right side equal to 0. So x squared minus 4x minus 45 equals 0. Two numbers that multiply to give you negative 45 and negative 4 add up to give you negative 4. We're going to have x minus 9 and x plus 5. Then we have to set them both equal to 0. So x equals positive 9 or negative 5. Last thing, we just have to plug it back in. So if we plug 9 into our equation, we're going to get both positives for 9 squared and 4 times 9 plus 45. Our second option is plugging in negative 5. Negative 5 squared is going to give you positive 25. And then negative 5 plugged into 4x is going to be negative 20 plus 45, which is still a positive answer. So x is going to have two values here, 9 and negative 5. All right, number 5 is just all about rearranging letters. So W, H, F, and J, R, N. We switched it around to J and R, so all we did was switch these back to, which means all we have to do is switch these back to. So it's going to be W, F, H, which is answer D. All right, number 6, it says use the following information to solve for x and y. It says AB is equal to 2x minus 3y. DF is 3x plus 6y. DE is 2 and AC is 45. So if ABC is equal or congruent to DEF, then AB is equal to DE and AC is equal to DF. So we're going to take these pieces and we're going to set up two equations or a system of equations. So we're going to have 2x minus 3y equals 2 and 3x plus 6y equals 45. I'm going to go ahead and cancel out our y's since we can multiply that 3y times 2 to get it to cancel out. So we're going to have 4x minus 6y equals 4. Make sure you distribute that 2 to all three parts inside. Next, we're just going to add the equations. So we're going to have 7x, 6y minus 6y is 0. So 7x equals 49. Divide through by 7, and x equals 7. The last thing we have to do, I'm just going to go ahead and take that first equation, 2x minus 3y equals 2. I'm going to replace that x with 7. So 14 minus 3y equals 2. So I'm going to subtract 14 from both sides. So negative 3y equals negative 12. Go ahead and divide by negative 3. And y equals 4. So we should get x equals 7 and y equals 4. All right, it says if we know that ABO is congruent to CDO, how do we know that B is congruent to D? So we talked about this very briefly. If they're in the same spot on the equation in the congruency statement, that's called CPCTC, or the corresponding parts of congruent triangles are congruent, which basically just says if you know the triangles are congruent, then the parts that line up together are also congruent. All right, on to number 8. I know it's kind of hard to read, so I'm sorry. But it says if ACB is congruent to TRS, which are not congruent. So first we have AB, which is the first and third, and TS, which is the first and third. So AB and TS checks out, okay? Because remember, we're going for not congruent. Then we have, ST and BC. So ST and BC, they do not line up. So ST and BC are not congruent. All right, checking the others. It says AC and TR, those match up first and second letter, first and second letter. And then our fourth one says SR and BC. So second and third letter, second and third letter. So those two are congruent. So B is our answer of which ones are not congruent. All right, let's look at number 9. Number 9 says, determine if the following triangles are congruent. If they are, state the method you used and write the congruent statement. So since we have parallel lines, we can prove that some angles are congruent. So in this case, we have KL is parallel to MN. Remember, that's what those little arrows mean. So if we use that and we use this line right here, then we're going to have this interior angle, these corresponding angles that are congruent. So now we have two sides that are congruent and the angle, and if we go in order, we have a side, then an angle, and a side. So our method is going to be side, angle, side. And then if we list these, our congruency statement, I'm going to go JLK. So triangle JLK is going to be congruent to triangle LNM. I think that's what that letter is. Yeah, LNM. So there you go. All right, it says find the value of x so that ABC is congruent to DEF. It says BC and then EF. So since they're in the same spot in the congruency statement, that means they have to be equal to each other. So we're going to have x squared plus 10x equals 24. Has to be equal to 0, so we got to move that 24 over. So x squared plus 10x minus 24 equals 0. We need two numbers that multiply to give you negative 24 and add up to give you a positive 10. In this case, that number is a positive 12, negative 2. So 12 times negative 2 is negative 24. When you add them together, you get a positive 10. Then we just have to set both of those things equal to 0. So x equals negative 12 and x equals positive 2. Last thing is we just have to plug them back in. So if we plug in negative 12, we're going to get negative 12 squared plus 10 times negative 12. So 144 minus 120, which is a positive number. And then if we plug in a positive 2, we're still going to get a positive number because there's no negatives there. So both of our answers, negative 12 and 2. All right, number 11. This one's going to be super helpful to draw out. So if we have triangle KJL, so KJL is congruent to triangle BFG. So BFG. All right, it says K is 32 less than 7 times x. So you'd write that as 7x minus 32. J is 27 less than 5 times x. So 5x minus 27. And x is 7 more than 3 times x. So 3x plus 7. Okay, it wants us to find the measure of angle G. So what we're going to do here is set J and F congruent to each other because the triangles are congruent, so we know that J and F are equal. So 5x minus 27 equals 3x plus 7. Subtract 3x, add 27. So we're going to get 2x equals 34 and x equals 17. Okay. From there, what we have to do is go ahead and figure out what G is. And what we can do here, if we know that L and G have to be the same, then we're just going to go ahead and plug x into angle K and angle J, and then figure out what that is, add it together, and subtract from 180. So angle J is 5 times 17 minus 27. Oops. 5 times 17 minus 27, which comes out to be 58. And angle K is going to be 7 times 17. And then we're going to subtract 32, which is 87. And then our last thing, angle G is going to be 180 minus 58 minus 87, which comes out to be 35. So angle G equals 35. Okay, let's go ahead and move on. Number 12. So moving on to proofs. Our first proof says that Kn is congruent to Lm. So Kn is congruent to Lm. Our second step also says that Kn is parallel to Lm. So we have that information right there, okay? So I'm going to go ahead and write those givens down. So Kn is congruent to Lm, which is given, and Kn is parallel to Lm, which is also given, okay? The next thing that we're going to do, if you guys remember, if you have parallel lines, you can prove that angles are congruent. So in this case, we're going to have alternate interior angles here and here. So we're going to have angle MLN, and it's going to be congruent to angle KNL by the definition of alternate interior angles. And then, since these two triangles share a side, LN is congruent to LN by our reflexive property. Okay? So from here you have to decide which triangle congruence theorem we used. And what I do to see it a little bit easier is I'll draw the triangle out. So if we have angle or triangle NLM, which is that triangle on the right hand side, we have our reflexive side in the middle, we have the angle, and then we have a side. So if we go in order, we have side, angle, side. So these are congruent by SAS. All right, moving on to number 13. So 13 says that TY is congruent to YX, and that is given. And then it says that angle TVY, so TVY, V is our vertex, is congruent to angle XWY, where W is our vertex, and that is given information. Okay. So in this proof, we actually only need 4 steps. The only other thing that we can prove is our vertical angles right here. So that is angle VYT, again using Y as that vertex, and WYX, and that is our definition of vertical angles. Okay, so then now we have 3 indicators. We have an angle, and a side. So that means we have proved triangle TVY is congruent to triangle XWY by angle, angle, side. And we don't even need step 5. All right, let's look at number 14. Number 14 says PQR and TSR are right triangles. So PQR and triangle TSR are right triangles. That is given. Okay. Then it says R is the midpoint of PT, which is given. So if R is the midpoint of PT, we know that this part is equal to that part. And then it says that PQ is congruent to ST. So PQ is congruent to ST, and that's given. So knowing that we have a midpoint, we have to state which parts are congruent. So PR is congruent to RT by the definition of point. Once we've done that, we have a right angle. Across from our right angle is our hypotenuse, so we have that hypotenuse. Then we have another side of our triangle, which is our leg. So that means we have proved that triangle PQR is congruent to TSR by HL. All right, moving on to the rest. Just doing some proofs, or I'm sorry, some systems. Okay, so I'm going to go ahead and cancel out our y's since they technically both have a 1 in front of them. I'm just going to multiply this top one by a -1. So we're going to have negative 8x. Zoom in a little bit here. Negative 8x minus 1y equals 16. Then our bottom one stayed the same. So our y's are going to cancel out. We're going to have negative 11x equals positive 11. So if we divide by negative 11, x equals negative 1. So then what we're going to do is we're going to go ahead and just plug that in. So 8 times negative 1 plus y equals negative 16. So negative 8 plus y equals negative 16. Add 8 to both sides. And y equals negative 8. So our answer is x equals negative 1, y equals negative 8. All right, moving on to 16. So 16, again, our y's cancel out, or our y's are the same coefficient, which makes it nice and easy. So I'm going to multiply this top one by a negative 1. So we're going to have negative 7x minus 2y equals negative 24. This one's nice and simple. 8x minus 7x is 1x. 30 minus 24 is 6. So x equals 6. We're going to go ahead and plug that back in. 7 times 6 plus 2y equals 24. 7 times 6 is 42. So we're going to subtract 42 from both sides. So 2y equals negative 18. Divide by 2, and y equals negative 9. So x equals 6, y equals negative 9. All right, last two, some factoring. So numbers that multiply to give you positive 25 and add to give you negative 10. So those two numbers are going to be 5 and 5, but since they have to add up to a negative 10, we're going to have them both be negative 5, because negative 5 times negative 5 is a positive 25. Then we set it equal to 0, and x equals a positive 5. You can set them both equal to 0, but you're going to get x equals 5 for both of them since they're the same thing. And our last one, 3x squared minus 2x equals 2x squared plus 48. So since we have that squared, we're going to have to factor. So we're going to subtract 2x squared minus 48. So when we do that, 3x squared minus 2x squared leaves us with 1x squared. Then we have our 2x minus 48 equals 0. Two numbers that multiply to give you negative 48 but add up to negative 2 are going to be negative 8 and positive 6. Then our last step is to set them both equal to 0. So we're going to add 8 and subtract 6 from both sides. So we're going to get x equals 8 and x equals negative 6. Alright guys, I hope this helped. And make sure that you try and work through them and study them, and make sure that you do that at Elastic.